So the integral e to the x multiplied by cosine of 1 minus e to the x with respect to x. Okay. What do you think? What should be the u, the new variable? Question number 1, do you see the composite function form in the integrand integrand expression? If the answer is yes, what would be the inner function? And if you can identify the inner function, that's going to be the variable u that you're going to start the problem with. We have the product, the e to the x, and the cosine. Cosine of what? Cosine of 1 minus e to the x. So that's the inner function. So we let u be 1 minus e to the x. And then next part as a routine, find the differential. Differential is from the derivative multiplied by dx. Okay, so this is the derivative du by dx, which is negative e to the x. Okay, we got u and du. Back to the main part of the problem. We're going to start replacing terms. Since we have cosine of the inner function, the inner already set up as a u. So we write it as integral, the cosine of the u. For this part, the one that we haven't used yet would be e to the x multiplied by dx. I'm going to put them together, like let them sit next to each other. So you can see that that part you're going to have to replace with some terms of the du. The way that I showed earlier, to, to make it easier to manage, you solve for dx. That means you divide both sides by negative e to the x to get du divided by negative e to the x. This way, you can replace the dx directly with the du divided by some quantity term. So then replace more. Cosine u is set, so let it wherever it is and work on the rest of the problem. This is multiply the dx. Since we already solved in terms of the du, so we replace it with the du divided by negative e to the x. Now you can see that e to the x can be reduced. Negative sign involving into the integrand, so bring it outside, treat it as a coefficient. So negative integral cosine u with respect to u. Don't forget to put the du because that's an important piece to put together as an integral form. The problem clean enough. As you see, this is just the integral of the cosine function. Next question, what is the antiderivative of the cosine? Or what function that you use to find the derivative and it gives you cosine u? And that the answer would be the sine function. So sine of the variable u. You can verify it by finding the derivative because the derivative of sine is cosine. Okay, that indefinite integral, you add c at the end and finish up by replacing u with 1 minus e to the x. So the answer is negative sine of 1 minus e to the x and then plus c. So this is the final answer. All right, that's the final answer. And then, yeah, that's it. That's the term definite integral. It means we have the integral that has lower limit, upper limit, or the bound that you have to compute at the end. We are still dealing with the substitution rule or the use of technique. The function, the complicated one, if you see as a composite, you treat u as a gx or the inner function, and then find the term involving with the derivative of the u. The end goal, get into the simplified form of the integration as a simple function of the variable u with respect to u. Okay, fu du. The lower limit, upper limit will be changed into the term as you define u as a function gx. Okay, so the original part, because the integral involving x, so the lower limit is the x value, upper limit is the x value. When you transform into the u variable, because u is defined as g of x, if x equals a, the lower limit will be g of a, and the upper limit will be g of b. After you transform everything, every single part will be involving with the u variable. Earlier, we get the antiderivative as negative sine of 1 minus e to the x plus c, correct? Okay, so for the part that we get down to the step that we have negative, the integral of the cosine of the u du, recall the u is 1 minus e to the x. So the one that we did earlier, this is the indefinite integral because we don't have lower limit, upper limit. I'm going to show you with the same problem. If we have lower limit, upper limit going on, when we get to this step, okay, the upper limit, lower limit for this problem, I'm going to put it in right now. The lower limit 0, the upper limit is the natural log of 1 plus pi. So the differences between these two problems is with or without lower limit, upper limit. When you have lower limit, upper limit, this one is called definite integral. Okay, definite integral. Original problem here, that means the lower limit a equals 0. This is x equals a equals 0. And the upper limit x equals b, which is natural log of 1 plus pi. Treat the same way, introduce the new variable u exactly the same way. After we get to the simplified form, we get to the term, um, the negative sine u, correct? We don't add c because we're going to replace the lower limit, upper limit to compute the number at the end. So when you get to this part, since you transform everything into the u form, with the substitution u equals 1 minus e to the x. If x equals 0, the u will be 1 minus e to the power 0, which is 1 minus 1 or 0. If x or b equals natural log of 1 plus pi, the u is 1 minus e to the natural log of 1 plus pi. Okay, use the log and exponential property. Exponential and log, they are inverse of each other. So you can cancel e and the log as long as the coefficient of the log here is 1. So for the upper limit, u is 1 minus quantity 1 plus pi. Remember parentheses, we have negative in the front, so that's the sensitive part. Simplify to get 1 minus 1 minus pi or just negative pi. So we have negative pi as the upper limit, okay, at the upper limit. So this is the lower limit and this is the upper limit. So when we get to this step, the lower limit now is 0 because this is the u variable, and the upper limit u equals negative pi. And I'm gonna write in the better form so you can see it in the cleaner version. So we have negative integral from 0 to negative pi of cosine u du. When you work on the definite integral, after you introduce a new lower upper limit, you do not have to get back to the x again. You are done with the x part. Just work on the simplified version in terms of the u. And this problem, I like it because you can see we can bring different properties of the integration. The lower limit 0, upper limit negative pi. Upper limit is less value than the lower limit. So you can swap them. When you swap them, what happens? If you take the lower limit to be upper and upper to be lower, what property that we use?
Change the sign.
Yes, we change the sign. That means we're gonna apply the negative sign to the original form. We have negative and negative now becomes positive. The negative sign is gone. Integral negative pi to 0 of the cosine u with respect to u. The antiderivative of the cosine is sine of u. Put the bar in the back because we are dealing with the with the definite integral. The lower limit negative pi, upper limit 0. Replace the upper limit subtracted by replaced by the lower limit. So sine at 0 is 0. Sine at negative pi is also 0. So the answer for this problem is 0.